Measuring acceleration due to gravity. Woo!
Pros and cons for previous experiments. For the spark tape and graphs, our pros were a hard data copy, which were the dots on the tape, and we got to have lots of data because there were a lot of dots. Some of the cons were the friction that the machine caused as the tape was running through, and we weren't sure if the spark timer had an accurate oscillation, and some of the dots were too close to measure. The pros for the dropping ball was that there was no friction that would affect the ball dropping, and we got to watch it over and over again. The cons were the stopwatch was only to the tenths of a second, so there were multiple frames for each measurement, which made it difficult to record exactly when the ball was at a specific point and time. There was a slow shutter speed, which led to the frames blurring together, so we had to guess where the ball was. The pros for Amanda skateboarding down the hill was all the times were similar. It accelerated kind of slowly. There was an accurate distance measurement, and we could repeat it several times. The video app provided accurate data points. The cons were that the radar gun didn't really work well at low speeds. There were two groups using the same data, and they got different values for the acceleration, and the hill wasn't perfectly smooth, and there was no acceleration due to gravity.
Okay, so the purpose of this experiment was to calculate the acceleration due to gravity. In this experiment, we used a small black ball, a meter stick, the iPad video physics app, and a piece of paper with measurements on it in centimeters.
So this is a very rough drawing of what our experiment looked like. We have Amanda dropping the ball from a height that I can't remember, and that's a meter stick.
Say that.
And then we have me filming with the iPad.
And with his awesome afro. Okay, procedure. Step 1. Tape a large piece of paper to the wall. Measure out increments of 10 centimeters with a meter stick on the piece of paper. Step 2. Using the video physics app on the iPad for video analysis, time and record the dropping of the ball against the background of the measured paper. Using video app, scroll through frames and record the height at which the ball was dropped. Step 3. Use video physics app to plot points on velocity time graph. Using the velocity time graph, find final velocity. Step 4. Use graphical app to find specific points on graph. Using these points in a graphing calculator, create a linear regression for data. The slope will be the acceleration of the ball due to gravity.
This was us collecting data, and this is the ball dropping. 2, 1, go. Fun stuff.
Here is our data. So here is the time in seconds at different times that the ball was dropping, and at these times the velocity was these values right here in meters per second. Then here's a handwritten copy of the data, which you should always have, just in case your computer dies or something. Okay.
Here are our calculations. We have our position time graph, which looks kind of like a parabola, and then we have our velocity time graph, which is a straight-ish kind of line, which it should look like. And here is this. Here's the same graph we used, and we plugged it into graphical, and that's what we got.
What is it?
That's our velocity time graph, and this is our position time graph again. This was we entered the values into the calculator, and we got our linear regression, which is negative 9.7. Should be negative 9.8.
Well,
so,
the slope is.
slope is negative 9.7. And this is our handwritten graph in our linear regression. We found our acceleration to be negative 9.7. And so we were very close to what it should actually be.
Okay, our conclusion was that in this experiment we used the video physics app to video analyze the motion of a ball being dropped outside in direct sunlight. So we had a faster shutter speed, that is important, against a white background, which is also important, so we had a faster shutter speed. Using the data from the video physics app, we transferred it to graphical analysis app. We then plugged our data into a graphing calculator and found the linear regression. The slope was negative 9.7, therefore the acceleration due to gravity was negative 9.7. This is very accurate since the accepted values is negative 9.8 meters per second squared, and this is only a 1% error. This 1% error is due to human error when plotting points on the video physics app. It is impossible to be exactly on the center of the ball every single point. And that was our experiment. Yay!